this lesson, we're going to talk about graphing, solving, and applications of linear inequalities. A linear inequality looks just like an equation, except instead of an equal sign, we have either a less than sign, a less than or equal than sign, a greater than sign, or a greater than or equal to sign. Let's take a moment to review interval notation. If you don't know what interval notation is, you may want to watch the previous video where I explain it. Interval notation is just a concise way of writing a set of numbers, and it's used in many different applications, and the higher that you get in mathematics, the more that you're going to see it. If we want to write x is greater than 5 in interval notation, we start by saying what is the smallest number in that set. Well, if x is greater than 5, the smallest number in the set is going to be 5. And the largest number in that set is going to be positive infinity. Since x is greater than 5, 5 is not included, so we use a rounded bracket. Infinity also is a number that can't be included in a set because we can never reach infinity, so it will also have a rounded bracket. And there's my interval, 5 to infinity. Let's do the same for the set of numbers that are x less than or equal to 4. The smallest number in my set is negative infinity because x is less than or equal to 4. The largest number in my set is 4. Since 4 is included because we have the equal than sign, we use a square bracket. Again, infinity or negative infinity can never be reached, so it always gets the rounded bracket. So x is less than or equal to 4 is the same as saying negative infinity to 4. Our next set is actually a compound inequality. We have two inequalities here. We're saying that negative 3 is less than x is less than or equal to 2. So this is two inequalities. X is greater than negative 3 and x is less than or equal to 2. So that means x is in between these two numbers. Negative 3 is going to be the smallest number in my set, and 2 is going to be the largest number in my set. Since 3 is not included, it gets a rounded bracket. 2 is included, so it gets a square bracket. And my last set of numbers, I have x is less than negative 1 or x is greater than or equal to 3. So here we have an or statement. X is not in between these two numbers, it's actually going in opposite directions of these two numbers. So x is less than negative 1 is going to be negative infinity to negative 1. X is greater than or equal to 3 is going to be 3 to positive infinity. To represent that word or, we use this union symbol. We can also graph our inequalities in interval notation. Sometimes it may even be helpful to graph first, then write what the interval is. So if I wanted to graph the inequality x is greater than 5, I have my number line. I always just use maybe 3 tick marks on my number line. 4, 5, and 6. X greater than 5 means I'm going to start at 5 and go towards positive infinity. Since 5 is not included, I use a rounded bracket. For x less than or equal to 4, again, I usually do 3 tick marks. 3, 4, and 5. We start at 4, we go to negative infinity, we go smaller. Since 4 is included, it gets a square bracket. So you could see how sometimes it would be easier to just have the graph first, because then you're just pulling the interval right from your graph. You can mark the infinities on there if that helps you as well. Here I have negative 3 to 2. x is greater than -3. So that's going to go in this direction. X is less than or equal to 2. That's going to go in this direction, and everything in the middle gets shaded. In our last example, I have -2, -1, 0, 1, 2, 3, 4. X is less than -1, or x is greater than or equal to 3. And again, if you were to graph first, you can draw your infinities on your graph and then write your interval from there. -infinity to -1, 3 to +infinity, and then your union symbol. Now let's talk about solving linear inequalities. So the solution set to an inequality is a set of numbers that makes the inequality true. When we had a linear equation, we either saw that there was one value that made the equation true, or we had no solution or infinitely many. Here there's going to be multiple or infinite numbers that's going to make that inequality true. Two inequalities are equivalent if they have the same solution set. So let's think about the difference between two items being equal and two items being equivalent. If something is equal, then it's the exact same thing. If something is equivalent, it just means that it means the same thing. So if you think of equivalent fractions, we know that 1/2 is equivalent to 3/6. They're not equal because they're not the exact same numbers, but they are equivalent to each other. They represent the same value. In order to solve a linear inequality, we're going to follow the same rules as solving a linear equation, except one big thing. When we are multiplying or dividing by a negative number, we need to flip the inequality symbol. So if I multiply or divide by a negative number and I have the greater than symbol, that's going to turn then to the less than symbol. Alternately, say if I had the less than or equal than symbol, it's going to change into the greater than or equal than symbol. And the same is true for the other combinations going from one symbol to another. So let's take a look at a couple examples. Here I have 4x minus 3 is less than or equal to 5. So let's solve the inequalities, graph the solution on a number line, and then write the solution in interval notation. So I'm going to follow the same rules as if this is a linear equation. So 4x is less than or equal to 8. Here I'm just dividing by a positive number, so nothing with my symbol is going to change. X is going to be less than or equal to +2. If I were to graph that, 2 is included, so it's a square bracket, and I graph on the number line. So my interval here is from -infinity to 2. One thing that's important is that you graph on the actual number line. If you give a graph like this is incorrect. And the reason why is that when you graph on a number line is one dimension, meaning that we don't have, say, a y value. We're not going to be above the graph. It doesn't make sense. It's not mathematically accurate. When we're graphing on a number line, we need to graph on the actual number line. So if you need to, like I do, I kind of shade it in to make sure that you could see where my solution set is, then do that. In our next example, we have 5 times x plus 1 is less than 3x minus 7. So 5x plus 5 is less than 3x minus 7. It doesn't matter if you move your x values to the left-hand side or the right-hand side. I tend to always move my x's to the left-hand side because it's easier to read the inequality that way. But I can move this 5x over if I wanted to. So 5 is less than negative 2x minus 7. Then add the 7. 12 is less than negative 2x. I'm going to divide each side by negative 2. Since I divided here by a negative number, I have to flip my inequality symbol. So let's make sure that we read this correctly. We have negative 6 is greater than x, which means x is less than negative 6. If you think that you would have a hard time reading this, especially at the beginning, you might want to always move your x terms over to the left-hand side. So my interval here is going to be negative infinity to negative 6. In these next two examples, you see that I have some fractions. If we remember our rules for solving linear equations, we try to get rid of the fractions. It just makes the problem a little bit easier to work with. So here I have 6/7 x is less than 1/3 x plus 1. So we look at our denominators and we try to find a common value. This is actually pretty easy since 7 and 3 are both prime numbers. We would just multiply them together to get the LCD. So my LCD for this first example here on the left is going to be 21. That means I'm going to multiply every single term, not just the fractions, but every term by 21. 7 and 21 cancel here, and I have 3 times 6x. So 18x is less than 7x plus 21. And we see this is already much easier to solve than the previous example that I had. So I'm going to subtract 7x from both sides. 11x is less than 21. Divide by 11. X is less than 21/11. Again, we don't write mixed numbers. We just leave them as simplified and proper fractions. This is as simplified as it gets, so this is how I'm going to leave my answer. I can write it in interval notation by saying that I have negative infinity to 21/11. If you were to graph this, a very, very easy way to graph it is to actually put your tick marks as fractions. So I'm looking for 11ths. Well, if I have 21/11, this is going to be 20/11. This one here is going to be 22/11, or you can even write that as 2. And then just graph. That way you don't even have to think about what 21/11 is going to be as a decimal. Just put fractions on your number line. It makes it much easier. In this next example, there are a couple ways that we can attack this problem. We can either find the LCD and multiply each term, which means we would multiply these 3, or because I have a fraction inside, you may want to just distribute this first, get rid of those parentheses, and then multiply through by the LCD. It really doesn't matter which way you solve the problem, which way you start. So I'm going to distribute because it's something different that I haven't shown you yet. I have 5/6 minus 1/3 x is greater than or equal to negative 5/18 x minus a negative, so that would be a plus 1/3. Now that I have all of these separate terms, I don't have this kind of weird factor times a multi-term factor going on. I could just multiply each one of these terms by the LCD, which is going to be 18. I'm going to switch colors so it's a little easier to follow. So 18 and 6 are going to reduce. 3 times 5 is 15. 18 and 3 are going to reduce to 6. 6 times negative 1x is negative 6x. is greater than or equal to, the 18's cancel, I have a negative 5x. And lastly, the 3 and the 18 cancel, and I'm left with a 6. Much, much easier than the original equation that we had. I'm going to add 5x to both sides. I'm also going to subtract the 15 in this step. So I have negative x is greater than or equal to a negative 9. Divide by negative 1. Since I'm dividing by this negative number, I flip my inequality symbol. So x is less than or equal to a positive 9. So that means my interval is negative infinity to positive 9. Let's take a look at a couple examples where we would use an inequality to solve. A student scores 74% on a test. What score does the student need on the next test to maintain at least an average of 80%? So we know that we are looking for the next test score. So we're going to let x be the score on the next test. I know to take an average, I would take the two scores that I have and divide them by 2. So 74 plus whatever the score is on my next test divided by 2 is going to be my average. I want at least an 80. So that means I want an 80 or higher. So I need this fraction here to be greater than or equal to 80. And now I can solve this inequality. I would start by multiplying each side by 2. 74 plus x is greater than or equal to 80 times 2, which is 160. Then subtract 74. X has to be greater than or equal to an 86. So the student needs an 86 or higher. In this example, a car rental costs $25 per day plus 20 cents per mile. If someone has $200 to spend and needs to drive 90 miles each day, for how many days can that person rent the car? So we're going to let D be the number of days. So we know that the car rental costs $25 per day. So that's part of my equation, 25 times D, plus 20 cents per mile. And we know that this person needs to drive 90 miles per each day. So that's 20 cents for the 90 miles, and that's going to be every single day that they have this car. We know that they only have $200 to spend. So this expression here needs to be less than or equal to $200. They can't spend more than that. So I have 25 times D plus, when I simplify this, I have 18 times D. That needs to be less than or equal to 200. 43D is less than or equal to 200, and I could divide each side by 43. So D needs to be less than or equal to 4.6511. Now, since I can't rent a car for a fraction of a day, that means that we can only rent this car for 4 full days.